Hello again. So today we're running this steel at approximately 6 kilowatts, more than 6 kilowatt, I would say 6.4. Okay, I will say 6 kilowatts. Here's the water that's been reduced from the container of the crude alcohol. It's been about 35-40% crude alcohol. It's been stripped with a stripping column. And now we're running some fractional column, or like continuous reflux steel. So, as I mentioned before, it's possible to control the reflux ratio here. Also, you can observe the level of the spirit within the dephlegmator. So you would be able to increase or decrease the percentage of the alcohol. You can control it up to 90-95% continuously, not a problem. Here we've got constant removal of the heads. It's dribbling continuously, it's all automatic, but also can be controlled. All the reflux is done automatically. Here we've got tails. There's a control valve. We're controlling the amount of tails to remove, and you can calculate the amount of tails according to the actual flow of the final product. And there's a certain formula could be applied, and you can calculate the amount, or you can just remove as much as you want. Some people who would like to retain all the flavor can allow more of this stuff to penetrate the final product. Not a problem. There's a couple of ways of controlling this. So the most awful tails still can be removed, and you can open up the reflux valve, and there would be almost no reflux, and you will increase the production speed, decrease the percentage down to maybe 75% continuously. I don't know if you see it, it's dribbles there. Yeah, there's the drops. So the bottom fraction, and here is water. It's stripped water, or in some cases it's all depends on the way you are operating these steelets, and you can use either all heating elements or half of the power of the steel. You can control it the way that there wouldn't be any leftovers of the alcohol over here, but in most cases the bottom fraction, or like tails, are still settled here in a reduced water. Also, it could be like a low grade alcohol over here as well, and you can still reprocess it later with a stripping steel. So just add it to your mesh and process it again. Nothing is lost. Nothing is lost at all. Here's a steam generator over here, and you can see the water level is kept continuously at the same level all the time. And again, there is no physical contact between the steam and the spirit in this particular column. The water and water steam is acting like a medium, and just transfer the heat through the walls of the an extra boiler, like a secondary alcohol boiler that settles or installed just within the boiler, within the water boiler. So water boils around the vessel, which is filled with stripped alcohol, and then it just raises up here, and it penetrates the column. There's a special pocket within the column that collects all the bottom fraction, reboils it. So the real bottom is a real bottom fraction, and a little bit high it's a proper one. It still operates. And here we've got physical column. It's packed with stainless steel. You can repack it with copper if you would like to. It's up to the customer. What else? And again, here's a reflux valve. Sorry for the lighting. I mean the lack of lighting over here, and I don't know. Yep, like that. Anyway, here's a column. It's running successfully for a few hours now. Here's a spirit we're collecting. So when we started to talk, it's been empty. Now you can observe the percentage is about 90%. Come on, turn around. Yep, somewhere around 90% continuously. Something like that. So it's not a true fractional cold. It doesn't strip all the flavor, and it's recommended for secondary distillation of whiskey and brandy, probably rum or something. Probably should try to run mesh directly through this column, and probably the result is going to be very good. Maybe this column could be used as a single stage column for mesh distillation, like rum or wine or something. We'll see. Okay, thanks a lot for your attention. See you next time.